friends, welcome to my YouTube channel. My name is Ranjiti. I am pursuing a BTech in Institute of College of Engineering, semester 3rd, lesson 123 CS 138, subject Digital Design and Computer Organization. Operation of logic gates and NAND or and NOR with single circuit using BJT, bipolar junction transistor, and gate. Logic gates are important parts of digital or electronics. These logic gates are mainly used to perform a logic operation between two or more input functions. Generally, for every logic gate, we have only one input, but in case of inputs, it may vary because we have two input logic gates, and some of the logic gates are also available for three input also. But for logic gate, this logic gate called not have only one single input and single output. These logic gates only take the binary data as input. Logic gates there are Logic gates used in circuit there are four types: AND gate, OR gate, NAND gate, and NOR gate. Logic gate AND. It takes two input and gives only a single output. The main operation of this AND gate is Z equals to A dot B, where A and B are two inputs and Z is output. Logic gate NAND. It takes two input and gives only a single output. The main operation of NAND gate is Z equals to A dot B, where A and B are two inputs and Z is your output. Logic gate OR gate. It takes two input and gives only a single output. The main operation of this OR gate is Z equals to A plus B, where A and B are two inputs and Z is output. Logic gate NOR. It takes two input and gives only one output. The main operation of this NOR gate is Z equals to A plus B, where A and B are two inputs and Z is output. Truth table of NAND gate. The input A and B, output Z equals to A dot B. If input A and input B is 0, the output Z is 0. If input A and B is 0 and input A is 0 and input B is 1, then output is 0. Input A is 1 and input B is equal to 0, then output Z is 0. If both A and B is 1, then output is 1. Truth table of NAND gate. If both input A and B is 0, then output is Z equals to 1. If both input is 1, then output is 0. If any one of the input is 1, then output is 1. Truth table for OR gate and NOR gate. For OR gate, if both output is 0, then output Z equals to 0. If one input is 1, then the output of OR gate is always 1. Truth table of NOR gate. If input both A and B is 0, then the output is 1. If any one output is 1, then the output is 0. Bipolar junction transistor. A BJT is a semiconductor solid-state three-terminal device. In BJT, current flows through two terminals called emitter and collector, and the amount of current is controlled by the third terminal called base. Working principle of BJT. Generally, a BJT consists of three junctions: base emitter junction, collector base junction, emitter collector junction. When the transistor is biased in the active region, then the base emitter region is in forward biased and the collector base junction is reverse biased. The width of the depletion layer of the base emitter junction smaller than the depletion layer of the collector base junction. Where B junction is in forward bias, it reduces the barrier potential and allows the electrons to flow from emitter to base. As the base region is lightly doped only a few volts, so only some electrons, 2% of emitter region, recombine with volts in the base region and flows out of the base terminal. This forms the base current which formed due to recombination of electrons and volts. The remaining The remaining large number of electrons will pass the collector junction to form a large number of collector current. The base current is very smaller than the collector current. This is the circuit of BJT circuit. From Kirchhoff current law, IB is equals to IE plus IC. The bipolar transistor can be used switches for LED because LED needs a small voltage at logical DC level. The areas of operation of transistors as a switch require two methods of saturation region and cutoff region. When the voltage of the BJT is in cutoff region, the transistor acts as a phase switch. When the voltage of the BJT is in saturation region, the transistor acts as open switch. This is circuit of BJT. This is the truth table of BJT input A and B. If both input A and B is low, then AND gate of output is low. NAND gate of output is high. OR gate of output is low. NOR gate output is high. If input of A is low and input of B is high, AND gate of output is low and NAND gate output high, OR gate output high, NOR gate output low. If input A is high, input B is low, and AND is low, NAND is high, OR is high, NOR is low. If both input B and B is high, and AND is high, NAND is low, OR is high, NOR is low. Yes, sir. One for A equals to low and B equals to low. For A equals to high and B equals to low. For A equals to low and B equals to high, both A and B is high. This is a circuit of for A and B is low. The truth table of cases A equals to low and B equals to low. Multimeter number XMM1, XMM2, XMM4, XMM3, logic gate and NAND of NOR. Readings 5.876 nanovolt, 2.075 volt, 19.009 nanovolt, 2.075 volt. Off, on. This is the readings of the XMM1, XMM2, XMM4 and XMM3. XMM1 is AND gate, XMM2 is NAND gate, XMM4 is OR gate, XMM3 is NOR gate. LED position off for XMM1, XMM2 is on, XMM4 is off, XMM3 is on. Thank you.